Hello guys and welcome back to this episode. In this episode I will teach you about using symbol editor which is used to create your own symbols rather than using the ones you already use in libraries. But why do you need to do that? For example, I want to use this OPA 206 op amp, this one. I go here to my schematic editor and I'm gonna search OPA 206 and I don't find one. Now you can use generic symbols and tie in your footprint to them, but that's not really nice. So I want to make my own footprint and my own symbol for this one. The footprint is for the next episode. Okay, so maybe for this part, basically you can go there and you can basically download it, but I'm not gonna download this thing. I'm gonna make it my own. So first of all, open the datasheet and go to the pinout. Here is the pinout of my op amp. So basically, I need to create this in KiCAD. Let's get rid of schematic editor and go to the symbol editor. Now, first of all, define the library that you want this to be in. My test library or my library that has everything I need, and new symbol. What is the symbol name? OPA 206. Very easy. Basically, you can copy one of those and modify it, but we don't want that. Designator, it's gonna be named U, like U1, U2, U3, basically for ICs like this. Keep this for one now because I'm gonna explain it later. This is because sometimes it is one symbol for the component, and other times there are multiple symbols for the component. Like if you have a big CPU, you have the RAM has a symbol, the CPU itself has a symbol, the power has symbols. We're gonna check that later on. Basically you can see these if you like them. Exclude from board, exclude from bill of materials. You don't need to do that, and all units are interchangeable. This is we're gonna dig into it later on when we start modifying this. Okay, maybe this is the good specs that you want. Click OK. Now it created this, and you can basically go to the symbol properties and you can basically try to edit anything that you want. Now, if you have a footprint already, you can basically assign the footprint to this schematic symbol so that when you put it in the design, it already has its correct footprint. And this is what I recommend usually. But now we still don't have a footprint yet because we're gonna make it in the next video. So let's get rid of that now. And basically, you see, you can make all of these changes right here. From where? From this panel. And now for the pin table. Pin table, basically, what are the pins of your device? These are the pins. Very easy. From 1 to 8, these are the numbers and these are the names. Okay, and you can have the table right here. But first, what you need to do first is basically to draw the symbol. So I'm gonna use one of these drawing tools and basically just draw a simple symmetrical symbol. You can make it an art, but that's not the episode for it. You can basically click here and edit. Do not fill, and I like to say fill with background color to be like this because this is what KiCAD uses. I'm gonna press save. So now it is saved, but it doesn't have anything. So I'm gonna use it in the schematic. It's basically useless. So now let's go for this area right here. All of these are the drawing tools that you already know, except for this one, drawing pins. So now let's get back to here. We need to put these pins one by one. Let's go for the input, the plus input. Its number is 3, which is this one. It is an input, non-inverting input. This is description. Let's see how can we mimic that in here. Pin name plus N. Pin number is 3. It is not a power input. It is an input. Or maybe you can make it unspecified because sometimes a DRC can make you an error if you connect stuff like this. I don't like that, but maybe you can just use it as an input. It is an input eventually. Okay, and now the orientation left on right. Basically, we can modify that later. Okay, let's make these choices. Basically, these are not really that nice except for the line. It is for right or for left. Let's make it for right. Okay, I'm gonna put it here. Okay, see, this is it. And now let's make another one. It's number 2, and it is the minus input. It's also an input, and it should be right here. Okay, now the no connect pins are 1, 5, and 8. Let's go here and make no connect number 1, make it unspecified, and put it right here. I'm gonna duplicate that by Control D. Let's go to pin number what? Number 5 and number 8. Number 5 is gonna be right here. Now, before I assign it, I'm gonna make it differently. Click E while not pressing it, and I'm gonna choose 5. Okay, unspecified, but I'm gonna make it. Let's keep it to the right. Okay, so if I put it right here, now I need to wire stuff from outside to the inside, which is not correct. I'm gonna move it and I'm gonna press X. It's gonna be mirrored, like we already know. It is now mirrored, and basically you can put it something like this, no connect, and can basically go on. But there's another choice to do, which is this, the pins table. Notice how it is not a nice organized table. I can press plus, and number 4 is the thing that we still didn't do. Number 4 is the V minus, which is this one. Basically it's gonna be ground, but it's a V minus. Let's put V minus. It is a power input. Okay, and now let's go to pin number 5. We already have one. Pin number 6 is what? Is the output. Out. And we want output, not power output, but signal output. And pin number 7 is the power positive. Its name is V plus. So it is 7 V plus power input. And lastly, pin number 8, no connect, unspecified. And now when I press OK, see, it has all of these already added. So I'm gonna like move them around, or maybe not. I'm gonna pick them one by one. This is number 8. Number 8 is gonna go here, but I'm gonna mirror it by pressing X. Make it nice and neat. This is pin number 1. I don't want that. Okay, move pin number 1. This is pin number 7. Pin number 7 is gonna be, if I rotate it, see, it's also gonna be okay. Pin number 7, and pin number 6, rotate that. Pin number 6 is gonna be basically right here. It's not really that much of an operation. It's just for, you know, how nice stuff can look. And this is number 4. It's gonna be in here. Pin number 3. Pin number 6. Pin number 2. Okay, let's say I'm satisfied with that. I'm gonna press Ctrl S to save, and that's it. Now, if you look at this, it tells you that it is an SOIC 8 pin. So I'm gonna go here. Instead of leaving it to the designer, I'm gonna go there, footprint, and choose SOIC 8. Of course, I need to check which one of them, but let's pick this one, for example. I'm gonna save it. See, now everything is fantastic. I'm gonna go here to the schematic itself. I'm gonna add a new device. I'm gonna call it OPA 206. Press OK. and there's my schematic. Very nice and very simple. Now, schematics can get more and more, let's say, difficult to be dealt with. So for this as an op amp, you can basically make another choice. Let's make another choice by having number of units 2. And they're not interchangeable, because interchangeable is like a 4 op amps in one package and stuff like that. No, not interchangeable, that all the units are different from each other. So I'm gonna use that. Now I have unit A and unit B. Unit A, I'm gonna keep unit A to be, see, I'm gonna move the powers and no connects. I'm gonna move them, and I'm gonna only leave, you see, I'm gonna only leave the op amp itself, the plus and minus. This is unit A. I'm gonna press and cut. Let's go to unit B, paste those in, remove, and let's try to make a nice adjustment. And let me tell you that it doesn't really need to be symmetrical, or it doesn't need to be exactly like the pins, like 1, 2, 3, 4. No, I can basically make anything I want. And those non-connects, I'm gonna make them all here. See, let's make it a little bit neater, and that's it. See, this is unit 1, it has the signals, and unit 2, it has the power. Now I'm gonna press save. Let's get back to the schematic. Let's get back and add the OPA. Let's add the OPA. Look at it, has U2, but now it's A and B. Now it has, you see, 2 units instead of 1 for the exact same component, and they both will have the exact same footprint. This is just one component, but it has multiple units. How can we make multiple units? I just showed you by going here, here and making this choice, and basically you can go as much as you want. If you have an FPGA or a CPU or a microcontroller that has like 100 pins, you're not gonna make a giant box that has 100 pins, and how can you even route that? You need to divide it. Make it something like this. These are the power inputs. Very nice. So if I'm gonna go right here, for example, I'm gonna have a capacitor. Give me a capacitor. This is a capacitor. See, I'm gonna go here. See the capacitor? See how easy it is to basically route it? Very nice. But if it is right here, see, I'm gonna go from from here to ground, and this I'm gonna put ground in here. It's gonna be messy. So maybe you have this in mind, or maybe you can, instead of having unit A be like this, you can basically make something like an op amp, and basically draw it as much as you want. So I hope that you have decided which type of footprints you need to make, and symbols. And if anything that is not really clear, please message me and join my Discord, and comment on YouTube. I'm gonna check everything. But for now, we consider this tutorial is done, and please be sure to watch the footprint tutorial, which gonna be next one, because that is the most important one. Okay. And in the meantime, check thundertronics.net and thundertronics.net/store for my products. And if you are willing to learn how I design those products, then you need to basically like, share, and subscribe. And I'll see you next time.